Alright guys, today we're looking at something that's pretty important because you're probably going to use it in your mathematics moving forward for the rest of the time you're at Villanova. So it's the formal division algorithm. And I know a lot of people sort of already know how to do this, but I just want to go over the language, go over the set out, and a few smaller things to make sure we're all doing the right thing, because the formal division algorithm becomes more complicated in term 4 and then as you move through the middle school as well. So a couple of basic definitions. Remember, an algorithm is just a way of doing something. So you can see here, this would be an example of an algorithm that's drawn up. This one I'm just doing 21 divided by 3 is equal to 7. The dividend is the number that you are dividing. So in this case, we've got 21 to divide. The divisor is the number we're dividing by, which is 3. And then the answer to any division problem is called a quotient. That's where the partial quotient strategy gets its name from as well. So let's look at doing a few little sums using the formal division algorithm. I've written down a couple on the side here. So I've got 4,575 divided by 3. So if you want to set this out in an algorithm, the first thing is drawing it on your algorithm. So 4,575 divided by 3. This time I've just drawn it like 2 straight lines. Here I've got that slight little bend to it. A couple of guys were asking me last week if there's a difference. Not really, it just depends on formatting. Sometimes some computer programs you can struggle to find a division symbol that looks like this. So this easy little bracket looking thing's easy. And then as you work through with the algorithm, you must start with your highest place value first. So we're going to divvy up our thousands first. And the question we ask ourselves is, how many times will 3 go into 4? We know that 3 will go into 4 once, and that'll be 3. And then there'll be one remainder, because 3 times 1 is 3, and one remainder to get us to that 4. So the remainder moves down, and the remainder is 1,000, and that'll go over and join with our hundreds. So now we're dividing 15 hundreds, and we ask ourselves, how many times does 3 go into 15? We know that 3 times 5 is 15, so it goes in 5 times with no remainder. Because there's no remainder, I don't need to write a 0 down here, I just keep working. Now I'm looking at 7, and I ask myself, how many times will 3 go into 7? It will go twice, and then 3 times 2 is 6, so there's one remainder. And then I've got 15. How many times will 3 go into 15? It will go 5 times. 3 5s are 15. And there's no remainder. 4,575 divided by 3 is 1,525. The algorithm's really useful for when you're trying to work out costs using dollars as well. So I want us to imagine that we've got $61 and we're trying to equally share that amount between 4 friends. So algorithm's the perfect place to start. 61 divided by 4. And then we start with our 10s. So we ask ourselves, how many times will 4 go into 6? I know that it's going to go once, and there's 2 remainder. How many times will 4 go into 21? Now it's not going to go evenly here, so we have to get as close as possible. So I know that 4 4s are 16, 4 5s are 20. So it's going to go 5 times, and there's one remainder. Now, as my working out, this is perfect. That's what you're looking for. You can extend yourself a little bit if you want. Because we've been asked to share this amount of money evenly, it doesn't really make sense to say we've got 15 remainder 1. Because if you're trying to share evenly, you can't have remainders. Now, there's some word problems that get you to round up or down, depending on the wording of the question. But this remainder 1 represents $1. Now, I know that I can share $1 amongst 4 friends, and I'm sure many of you can do it off the top of your head, but I just want to show you a step that you can do to show it in your working out as well. If you like, you can put a decimal place, and you can add some zeros after it, and then they just become like a place value, and we just keep working on the algorithm as we normally would. So for instance, this one was 4 times 5 is 20, and we were trying to divide 21. So I've got one remainder, which comes down here. Now all of a sudden I've got 10, and I ask myself, how many times will 4 go into 10? Put a decimal place here, because we've got to continue it. 4 will go into 10 twice, which is 8, with 2 remainder. The 2 comes down here. How many times will 4 go into 20? 4 will go 25 times, with no remainder. So I know my answer is going to be $15.25, and that 0.25 is 25 cents.